In this video, we're going to look at converting between polar and rectangular or Cartesian coordinates. So here we have a rectangular coordinate grid and a polar coordinate grid to kind of visualize what's going on. So I'm just going to put a point here. So if this were a point in the Cartesian or the rectangular plane, this would be xy. Or if it was a point in the polar plane, this would be r theta. So if we use some trigonometry, we can look at what this would look like. So here, this is my r value, remember, because r is the directed distance from the pole or the origin. If I go from the point down to the axis, this is my y value, because that's my vertical distance. If we go from the point over, this is my x-axis. And then remember, this angle right here is going to be my theta value. So some things that we know from trigonometry are simply that this is a right triangle here, so I know x squared plus y squared equals r squared. So if I have my x and y coordinate from the rectangular plane, then I could find my r value by using this equation. We also know from trigonometry that the cosine of theta is going to be the adjacent side over the hypotenuse. So we know the cosine of theta is going to be x over r. We know the sine of theta is going to be y over r. We know the tangent of theta is opposite over adjacent, so that's going to be y over x. So I can use these two equations if I have my polar coordinate, if I have r and theta and I want to find the rectangular coordinate x and y. So if I just take this equation and solve it for x, I get x equals r times the cosine of theta, and this second equation, y equals r times the sine of theta. So if I know r and theta, I can find x and y using these two equations. I can use these two equations then if I have my x and y coordinates, or if I have my rectangular coordinates and I want to find the polar coordinates. So what we end up with here is r is equal to plus or minus the square root of x squared plus y squared. And theta is equal to the inverse tan of y over x. So notice I can get a positive or a negative r value. And then this tangent equation, tangent theta equals y over x, remember there are infinitely many answers to a periodic function when I solve the equation. So there are multiple different angles that I can use. So when we convert from rectangular form to polar form, we're going to get some options that we're going to have to look at. So just kind of taking another look at this here. These formulas in this box here will be given to you on the formula sheet, so you will have them, but you need to know how to use them. You don't have to memorize them. Okay, so if we're going to convert from polar form to rectangular form, so I'm going to come back here for a minute. So I want to find the rectangular form, so I want to find x and y, so I'm going to use these equations here. So this is just going to be x is r, which is 3, times the cosine of 5 pi over 6. And y is r, so 3 sine 5 pi over 6. So then we can either use the calculator or we can use our circle. So we know the cosine of 5 pi over 6 is negative radical 3 over 2. So x is 3 times negative radical 3 over 2. And y, the sine of 5 pi over 6 is 1/2. So we're going to get 3 times 1/2. So my point is negative 3 radical 3 over 2 and 3/2. On this second example, we have the point to negative 200 degrees. So remember, this is r and this is theta. So here I'm going to go x is 2 times the cosine of negative 200 degrees, and y is 2 sine negative 200 degrees. So here I'm just going to use the calculator, so remember, make sure you're in the appropriate mode. So here we end up with x is about negative 1.88 and y is about 0.68. So my point is negative 1.88, 0.68. All right, so here we're going to do the opposite. We're going to convert from rectangular form to polar form. So remember, there's actually infinitely many answers here, so it takes a little bit more work. We got to think about a couple things. So the first thing I want you to do is just kind of plot your point. So this is the point -1, +1, so I would be in quadrant 2. So it's important to know our quadrant because we got to think about our angles. It's important to know the quadrant because you have to think about your angles. So now I'm going to use, remember my formulas, r is equal to plus or minus the square root of x squared plus y squared, and theta is equal to inverse tan of y over x. So then the first thing we're going to do is we're going to say r is plus or minus the square root of -1 squared plus 1 squared. So r is plus or minus the square root of 2. Then we're going to say theta is going to be equal to inverse tan of -1 over 1. So let's work in degrees right now. So we're just going to do that on the calculator. So negative inverse tan of -1 gives us -45 degrees. So theta is -45 degrees. So remember, with tangent, I can also get any other solution for tangent by adding or subtracting pi or 180 degrees. So I'm going to find my other value for theta, which is going to be -45 plus a half circle, which in this case is 180 degrees, which is going to give us 135 degrees. So now I've got two values for r, plus and minus radical 2. I've got two values for theta, -45 and 135 degrees. So now we just have to figure out how these pair up to be in the appropriate quadrant. So if I use the positive rotation, so if I come out to radical 2, positive radical 2, and then I rotate over here, I just need to look at this and say, is this a -45 degree rotation or a 135 degree rotation? So this is more than 90 degrees, so it's the 135. So then we have radical 2, 135 degrees. So then that means if we have negative radical 2, that would be a -45 degrees. So if I came out to the negative radical 2, and then I would rotate this amount here, which is -45 degrees. All right, so our second example, we have the point -3, 0. So here I'm actually on the axis, so I'm right here. So again, I'm going to start with r is equal to plus or minus the square root of -3 squared plus 0 squared. So r is going to be plus or minus the square root of 9. So r is plus or minus 3. And then we're going to go theta is inverse tan of y over x, so 0 over 3. So theta is the inverse tan of 0. So this time, if we work in radians, we can think about our circle. Where's my tangent value 0? Well, that happens at 0. And then again, I want to find my additional answer, so I'm going to add a half circle. So theta could also be 0 plus a half circle. Since I'm working in radians here, we're going to say pi. So theta could be pi. So again, I have 0 and I have pi for my theta value, and I have plus or minus 3. So again, I just have to decide how they match up. So if I come out to positive 3, I have to rotate to get over to Q, and that's a half circle. So this is going to be positive 3 goes with the pi, which means -3 would go with the 0. All right, you can use your calculator to do these conversions. It's in your angle menu, so if you do second apps, remember to get to your angle menu. Your bottom choices are the ones that will help you with this conversion. So these first two are if you have rectangular, so the capital R stands for rectangular, so rectangular convert to polar R value, and rectangular convert to polar theta value. So you have to do two separate functions to get each coordinate. And then the bottom two, 7 and 8, are if you have polar and you're converting to rectangular x coordinate, and polar convert to your rectangular y coordinate. So, okay, so if we come back to the examples that we just did, take the calculator. You want to make sure you're in the appropriate mode. So this one here, we had 3, 5 pi over 6, so I need to be in radian mode because my angle that I'm given is in radian mode. So I'm going to make sure that I'm in radian mode. And then I can go second, apps to get to the angle menu. And then I have a polar and I want to convert to rectangular. So I'm going to come down to number 7. So I'm going to be polar to rectangular x. And then I have to type in the point. So 3 comma 5 pi over 6. And this gives me negative 2.598, etc., which should be equivalent to what we had here. So negative 3 radical 3 divided by 2. Gives us that exact same value, so it's giving you the decimal answer. Now remember, that's just the x-coordinate, then we have to go through that process again to get the y-coordinate. So again, I'm going to go second, apps, and I'm going to go down to number 8 now. And again, we're going to type in the point 3 comma 5 pi divided by 6. And here I get the 1.5, which is equivalent to 3/2. Looking at the other example here, we had this point negative 1, 1. Remember that here we converted and we used degrees, so I want to make sure I'm in the appropriate mode. So again, here I'm going to go back and I'm going to change to degree mode. Then we're going to do second, apps. Here I have the rectangular form and I'm trying to get to polar, so I'm going to come down to number 5. I'm going to put in the point negative 1, 1. So this is giving me 1.41, which is the positive r value. It's the same as square root 2. So we can see that. And then I want to get the theta value. So again, I'm going to go back second, apps. And I'm going to go down to number 6 this time. And again, I'm going to put in my point, negative 1, 1. And I get the 135 degrees. So using your calculator, it will match them up for you. And you don't have to try to figure out like we did when we did it by hand. Okay, also we're going to look at here finally the distance between two polar coordinates. So if we have 2 points P and Q, which are defined by RA and SB, the distance between them can be found by using a variation on the law of cosines formula. So the distance between them squared is equal to r squared plus s squared. So those are the r values from each of the points, minus 2 times rs cosine of the difference between the two angle measures. So here if we want to find the distance between 3 70 degrees and 7 150 degrees. So let's just visualize that for a minute. So 3 70 degrees, if I come out to 3 and I rotate about 70 degrees, I would be here. So this would be my first point, 3 70 degrees. And then my other point is 7 150. If I rotate 150 degrees, I'm going to probably be over here. So this is my second point, 7 150 degrees, and then we're trying to find this distance between them. So to find that distance between them, we're going to say that the distance squared is equal to 3 squared plus 7 squared. So I'm taking the r value from each of those points, minus 2 times 3 times 7 cosine, and then I want the difference between the angle measures, so 150 degrees minus 70 degrees. And then I'm just going to use my calculator. Again, check that you're in the right mode. My angles were given in degrees, so I want to be in degree mode, and then we can just put that in. So I'm going to type in the formula, and then remember that's my distance squared, so I have to take the square root of it to get the actual distance, and we come up with our distance is about 7.12. So another example here, we're looking at radar tracking. We've got these 2 points and we want to find the distance between the 2 airplanes that are noted by these 2 points. So I'm trying to find this distance. So again, we're going to say 8 squared plus 5 squared minus 2 times 8 times 5 cosine 110 minus 15. And then we need to square root that in order to get the distance. And we end up with about 9.8 miles.